All right, so this video is going to be just some practice with factoring. We have a bunch of different factoring techniques that we use. I have a student with me this time, so there might be questions asked in the video. So hopefully the student will ask questions that everyone is struggling with at this time. Now, usually when we learn factoring, say, in middle school, and we tend to focus on a certain type of example. The type of example you might even be picturing, just to grab another worksheet, might look something like, just to throw one over the camera, something like this. This is what usually people associate with factoring. This is something that's called a quadratic. Quadratic means the highest degree is 2. Trinomial, which means we have 3 terms. So not everything's a quadratic trinomial, though. We also have quadratic binomials, and these are both binomials in different ways. They both get factored in different ways. And even on this set of examples that we'll be doing today, this is a quadratic binomial, a different type of quadratic binomial. This over here is a cubic polynomial of 4 terms. But really, methods that we'll use can be carried through and used on all of these examples. Down here, we have a quadratic trinomial, maybe a little bit more classic, comfortable looking. This is a special cubic binomial, and this one is actually a quintic polynomial, and we're still going to use the same methods that we've been using. So what should we really know about factoring? What do we need to be good at? What do we need to be comfortable with? So I'm going to throw a few examples at us right now and kind of derive this factoring technique for us. So here I have just a little index card, a little scrap paper for us. If we multiply things, if I multiply certain binomial expressions, sorry, there's a lot of shadow coming in, but we'll do the best we can. If we multiply certain binomial expressions, for example, say I have something like 3x minus 7 and 2x plus 5. When you were in Algebra 1, pre-algebra, you FOILed is not really a verb, but you multiplied expressions like this. So this first one, I'm just going to call this big pink rectangle, right? And it's a little squinty, but this is going to be my big pink blob. Now, if I multiply the big pink blob by 2x plus 5. Well, whenever you distributed in the past, say you had something like just 3. If it was 3 times 2x plus 5, you would have no issue. You would just be, well, I know I need to do 2x times 3, plus I know I have to do 5 times 3. If you don't show that step, maybe you jump right to 6x plus 15, but we seem to be comfortable with multiplying that type of a situation. But what about when it's not this type of a situation, right? So, saving that aside, it's a little baby example. So I'm going to multiply this pink rectangle by that. Well, what does that give me? 2x times what? Whatever is the pink rectangle, right? Then I'll have, there's 2x plus 5. I'll also have 5 times pink rectangle. Well, what is the pink rectangle? The pink rectangle is actually a binomial expression, an algebraic expression. Instead of it being just a 3, just this constant monomial, I have a linear binomial. So I'm really throwing in over here 3x minus 7, 3x minus 7. Well, that just means we have another level of distribution to do. 2x times this. Well, 2x times 3x is 6x. 2x times minus 7 is negative 14. It's not 6x, I'm sorry, 6x squared. And then that's minus 14x. Plus 5 times 3x is 15x. And then 5 times negative 7 is negative 35. Even if we go back to the first step, here I'm stopping here for now. I know I want to combine my terms, but if I go back to this first step, we also learned something called FOIL. FOIL is just a mnemonic device that taught you how to do multiplication of a binomial times another binomial. Well, when we do those, this will teach us a way so that everybody multiplies all the pieces in the same order every time. F stands for first. First term times first term. 3x times 2x. That gives you 6x squared. O stands for outer or outside. 3x is on the outside of the expression. And then on the other side, so these are the outsides. And these are the inside, right? 3x times 5 is 15x, so that's my outside. Inside, I have negative 7 and positive 2x. So that's going to be negative 14x. And then L stands for last. Negative 7 times 5 is negative 35. So really, I get 2 expressions that look very similar. The only difference is this one has negative 14x as my second term and 15x as my third. And this one has 15x and then negative 14x. It doesn't matter at the end of the day, because when you're done, you're going to combine my terms anyway. That will become negative 14 and positive 15 becomes plus, really a 1x. We don't normally write the 1, but I'm going to write it for right now. Minus 35. And here you get the exact same thing. Addition is commutative. When you're adding, it doesn't matter which order we add, as long as you follow all the rules. So either way, we finish and we get this thing called a quadratic trinomial. Now, it's easy to expand and then to multiply to get an expression like this, but the hard part is when you're given this, and I want you to go backwards and tell me where it came from. That's That's the harder part. And a lot of people, when we learn how to factor, I know when I learned how to factor, like, just do it in your head. So I used to play around and be like, okay, maybe it's 2x and 3x. What multiplies give me? So that's first and first, last and last. Maybe it's 7 and 35. So maybe I put the 7 here by accident and the 5 here by accident. And I check in my head and I say, outer's 10x, that's 21x. That won't give me 1x. And I used to just guess and check until I figured out the answer. But guess and check's not a method. Who was I fooling, okay? It does catch up to you when we get into more advanced examples. So the example I'm going to show, or the technique I'm going to show for factoring, is going to be called, some people call it the AC method. Other people just call it grouping. I kind of call it both. It's factoring using the AC method and grouping. So I'm just going to slide this up here for a second. And I'm going to pretend, if I gave you a test question or a quiz question, and I said, okay, I need you to factor the following example. And the example is what we came up with, 6x squared plus x minus 35. And I wanted you to factor this. A lot of people immediately get distressed because they're like, oh, I hate these examples. I hate when the first number is not a 1. A lot of people tend to really like examples where a leading coefficient is the number in front of the variable with the biggest degree. This is a variable. My biggest degree is 2 because that's x to the 1. And the number in front is a coefficient. So it's called a leading coefficient. When you do factoring, just showing a worksheet from the internet, okay? This is factoring trinomials, and they even point out A equals 1. Factor each completely. This is like a dream to some people. They think factoring these is so easy. But then as soon as we flip over and I give them the other side, this is when people get upset. They're like, oh, forget it. I can't do these. They're harder. Even it says A is greater than 1. That's what makes the examples harder. Okay. So a couple things for technique, for strategy. Normally when you FOIL, you create these 4 terms, which I see right over here. First, outer, okay, inner, and last. Having the 4 terms is wonderful. Do I have 4 terms here? No, I only have 3. I have the first term. I have the last term. But the OI in the FOIL, right, the outer and inner, what always happens with these 2 terms? Every time you FOIL, not every time, I mean 99% of the time, when we FOIL, the 2 terms combine because they're like terms. So instead of having an outer and an inner, we have a middle. And then we have the dreaded FML, right? Everyone knows, hopefully, what FML stands for. So when you see an example like this, you think to yourself, ugh, FML, I need to be able to factor this. So, next. We also need to know what standard form of this is. Standard form of a quadratic, I'm going to write it over here, is ax squared plus bx plus c. And we usually say standard form of a quadratic equation, and I can set it equal to 0, but by itself, it's a standard form of a quadratic expression, okay? With this part, again, that's an equation. Without that part, it's just the expression, no big deal. So what does that tell me? A is equal to 6. So I'm going to write that down a little note for myself. A is equal to 6. What does B equal? Well, the coefficient right here. So in this case, B is equal to 1. And then C is my constant at the end, and that's negative 35. Okay. When you look at an example to factor, and you just see you have first, last, and middle, you can say, oh, FML. I'm going to go to AC. Going to Atlantic City. FML, I'm going to AC. Let's go to Atlantic City. AC, so this is just the story we tell ourselves as we factor so that we can remember all the steps. AC means we're going to multiply the A value, which is 6, and the C value, which is negative 35. Now, again, this does not mean you have to bust out your calculator, okay? You can start small. 6 and 35. Handy tricks. All stuff that we're learning along the way that are going to help us with everything. 6 and 35, well, 6 is really 2 times 3. 35 is really 5 times 7. If you know how to break a number down, it'll help you multiply without going too crazy. So over here, what we'll do, okay, so I have this prime factorization, and in this prime factorization, I see I have 10, and I also have 3 times 7, which is 21, and 10 times 21 is 210. So right away, I know 6 and 35 makes 210, and they're both, well, actually, no, this is positive and negative, so it's actually negative 210, that does matter. And this prime factorization, I'm going to keep on the side right now, because I'm going to look at that in a second. So every time I have an FML, I say FML, I'm going to AC, and I'm going to go find all my pairs of factors in AC. So we're in Atlantic City, we're looking for factors. I do all of them down my list. 1 times 210. 2 times, well, the top is 210, 105. 3 times what? If you look over here, 3 is in the list. 3 times what? Well, what's 2 times 5, 10, times 7, 70. So 3 times 70. So what this does, this prime factorization, is it helps you see, like X-ray vision, what makes the number. So you can come up with your factors easier. 4 is not here. 5 is right there. So 5 times whatever's left over. What's 2 times 3? 6. 6 times 7? 42. So it's 5 times 42. 6 is here. Well, it was 6 times 35 to get us there, so it's still what it is. 6 times 35. Here's 7. 7 times 5 and 2 is 10. Times 3 is 20. What did I say? 30. 30. 7 times 30. 8 is not here. 9, 10. 10 and 21. I saw that one before. 10 and 21. 11, no. 12, no. 13, no. 14, 15. 15 and 14. Once you get to like square root territory, like 15 times 14 is close to the square root, you know you're done. So I'm done with the list, and then I go, okay, FML, I'm going to AC. I'm going to find all my pairs of factors. B for but what? But I have to pick the pair, B for but, B. I have to find the pair that adds or subtracts to give me 1. Which pair of factors that multiplies to give me 210 will add or subtract to give me 1? Yep, 15 and 14. So if I need a positive 1, the sign doesn't matter. I need a positive 1, that's a positive 15 and a negative 14. Will that multiply to give me negative 210? Yes. A positive times a negative is negative. Okay, now what are these numbers for? The F can stay, the L can stay. The middle is going to become OI. What do I mean by OI? OI, I mean outside and inside. So the F stays, the L stays, and we'll see a FOIL, and we could reverse our FOIL. Okay, so this is going to split up into 2 pieces. If this is x to the first power, these are going to be x to the first power. If this is x to the 10th power, these are going to be x to the 10th power. It'll match. So I write 6x squared plus 15x. No, I should have put 14 on the side, but whatever. Minus 14x and minus 35. Now I have my little bit of a song. It's not really a song, so I don't really sing. It's more like I just talk it the same way every time. Now, when you factor, say it was just something like this on a test or quiz, and they said, factor this. This is all you have. You can't factor it the way we like to look at the double bubble. What I mean by double bubble, I mean this, like 3x minus 7, 2x plus 5. That's not how we factor something like that. Okay? It's like if I said to you, factor this. If you have to factor this, you take out a greatest common factor, right? What number do they have in common? They both have a 3, so I factor out a 3. Now, factoring is undoing distribution. Distribution is associated with multiplication. That means factoring should be associated with division, because they really are the yin and the yang. They inverse, undo each other. So by underlining the first 2, I want to say to myself, underline groups of them. The groups must be the same size. So if I underline 2 things, I have to underline 2 things. That's why you need 4 items. You can't make groups because a group is not 1 item. You can't make a group unless you have at least 4 things. 5 things is not good. 5 might have to turn into 6. 6 things is fine. You can make 2 groups of 3 or 3 groups of 2. 7 things, not good. 9 things is okay. You can make 3 groups of 3. So we have options. Now, under this line is going to act as a way of grouping my information, but it's also going to act like a fraction bar. Underline, greatest common factor. What's the greatest common factor in 6x squared and 15x? Looks like they both have a 3, and they both have an x. And then the greatest common factor between 14, x, and 35, I think I would have 7. Now, whatever the sign of your first term, this is positive 6x squared, so this is positive 3x. This is a negative 14x, so then that's negative 7. Underline, greatest common factor. Bring it out front. Parentheses. So really, I'm undistributing the 3x. Somebody distributed 3x, I'm undistributing. But multiplication is easier for people to do in their head. So I want to kind of coach along for the factoring because the division's harder. So then I say, next I always say, pretzel. So those look like pretzels. And they're there for a reason. They're not just there for decoration. Those are there to show me what I'm dividing. So the bottom number, 3x, is dividing into both terms, 6x squared and the 15x. Negative 7 divides into both terms, negative 14x and negative 35. So you reduce it twice. What's 6x to the second divided by 3x? 6 and 3 reduces, squared and x reduces, we get that. Plus 15x over 3x is 5. Next, negative 14x over negative 7 is 2x. Negative 35 and negative 7 is plus 5. Now, earlier we saw an example where the big pink rectangle was a factor and it got distributed to everything. Well, here I have another big pink rectangle, but instead of it being a big pink rectangle, I have instead, let's do a light highlighter. I have a green one. I have something new in common. So remember, factoring is all about finding out what you have in common. So really, I know it's hard to wrap our minds around sometimes, but this is my whole entire first term minus my whole entire second term. what does my first term and second term, what do they have in common? What do they both have? They both have 2x plus 5, right? So they both have 2x plus 5. If I factor out the 2x plus 5, I'm going to pull this out front because they both have one. And it sits here, 2x plus 5. Well, then what's left inside? 3x minus 7. Boom, it's factored. So that's how you factor something, okay? So this is how you factor something when it's set up like this. But the thing is, this method that we just did, this part of it is the AC method. The AC method gets us to split up our middle term correctly. But then the grouping is sort of what we did from here on out. Okay, the AC method gets us set up right up to here. Grouping is the next method. Now, how can grouping work? It can really work on a ton of different things. So I'm just going to make up a crazy example right now to show you how grouping can work on something else. So let's say it doesn't matter because multiplication is commutative. So this answer is really the same as this answer because it really doesn't matter which way you multiply things, you end up with the same answer at the end. The thing is, whatever I get for my common factor, depending how I set my problem up, I always pull that up front because I want to think of it as being factored out. Okay, so I'm like, oh, I'm taking this out. What's left here is on the right. Okay, now I'm going to throw in this other example right now. I'm going to make up something a little different than what we've done. So let's say we had x squared. Okay, let's see. I can give x to the fourth plus 3x to the third plus 2x squared minus 4x squared minus 12 minus 12x minus 8. Okay, now this is a big crazy thing, right? Normally, if this was given to you, I'm going to go up a line. You see we have like terms in here. I have x to the fourth plus 3x cubed plus, these are like terms, really I guess negative 2x squared, so if I wouldn't have the plus sign, I'm just saying minus. These can be combined. Minus 12x minus 8. I have 5 terms. This is a quartic polynomial of 5 terms. If I ask you to factor this, most people will be like, that's funny, not doing it. What the heck are you talking about? But in this step, it's already set up nicely for you. If you have 5 terms, I cannot make more than one group where the groups are the same size. I would get a group of 2 and a group of 3, or I would potentially get 2, 2, and 1, but even that doesn't work. However, if I have it like this, okay, I could either do a group of 2, a group of 2, a group of 2, or I could do a group of 3, group of 3. One thing that you're looking for in your groups when you're doing grouping, just to kind of show it over here, back to this example. The ratio from 6 to 15 is the same as the ratio from 14 to 35. The ratio of 6 to 15 is actually the same as the ratio from negative 14 to negative 35. If I reduce this fraction, I could reduce it by 3 on top and bottom, and I get 2 fifths. And if I reduce this fraction, I can reduce by negative 7, and I also get 2 fifths. When you have this common ratio, that's what allows the grouping to happen. We're not going to be so conscious of it right now. As we get further in math, we'll get better at it. You're probably not even noticing it most of the time right now. I'm just pointing it out for us. Here, as you get better at this stuff, you'll look at an example, this one, and you'll be able to see these 3 terms right here and these 3 terms right here have a common ratio. This is 1, 3, 2. If I divide everything by negative 4, I get 1, 3, 2. I get that common proportionality between the 2 expressions. So I'm going to try my grouping song on this example, okay? Underline, underline, greatest common factor. What's the greatest common factor out of these? Next to the second. What's the greatest common factor here? Like a 4, but not x because this one doesn't have one, but negative. So bring it out front, bring it out front, parentheses, parentheses. Now, normally I say pretzel, so whenever I have to draw more than 2 ovals, to me it's now a peacock. Peacock? See? Another one. Or a turkey. We're close to Thanksgiving now, so maybe a turkey. Okay? So we have our peacock or our turkey feathers spread out over there. Peacock, peacock, what goes inside? Or turkey, turkey, whatever you want to call it. All right, reduce each. X to the 4th over x squared is x squared. 3x to the 3rd over x squared is 3x. 2x squared over x squared is plus 2. Negative 4x squared over negative 4 is x squared. Negative 12x over negative 4 is plus 3x. Negative 8 over negative 4 is plus 2. Now, if it matches, you're winning at life. Bring it out front. Well, what is it? It goes out front, x squared plus 3x plus 2. What's left inside? X squared minus 4. Now, we're not totally done factoring because actually I can factor this part and I can factor this part. The one on the right is pretty easy. I will do that in the next video. That's going to be what we call the difference of two squares. So if you need help with that, definitely you're going to watch the next video for that. I'm going to separate them. And then this one is a classic quadratic. We could do AC method. Some of you can get right to the answer. I will do AC method. So I have 1 times 2 is 2. So I'm just going to write a little 2 over here. AC equals 2. So I'm going to work for that, okay? 1 multiplies is going to be 2, 1 and 2. B for but what? But it has to add or subtract to give me 3. Well, plus 1 and plus 2. So that means we have x squared plus 1x plus 2x plus 2. Underline, underline, greatest common factor, this is x. That's positive 2. Bring it out front, bring it out front. Parentheses, parentheses. Again, some of you guys can jump right to the answer, that's fine. Pretzel, pretzel. What goes inside? That's going to be x plus 1, x plus 1. If it matches, you're winning at life. Bring it out front. What's it? X plus 1. What's left inside? So if I bring the x plus 1 out front, what's left outside is, inside is just x plus 2. So that right here, I'm just going to color it with the highlighter a bit. This factored is that. That was just the word for it. Now next to it I have, let's just do a different shade of yellow. Next to it I have this guy right over here. I'm going to factor it right there for now. Again, the lesson for that, if you need support, is going to be in the next video. But this is x minus 2 and x plus 2, if you remember that these are conjugates. So what's the final answer to this problem? It's all 4 of these in a row next to each other. However, if you notice, I have x plus 2 twice. Whenever you have something twice, you could just write it as. So I have x plus 1. I have 1x minus 2. I just have one of them. And then I have x plus 2. You have it twice. Yep. There it is. That is the factored answer. So what did I just do? I used grouping on something that had 6 terms. I made 2 groups of 3. So throughout the course, we're going to see a lot of opportunities to use this, and especially when you get to like pre-calc and calculus, these little guys are going to sneak up all over the place, and if you're really good, you'll catch it and you'll factor in no time. All right? Questions? This one's 2 groups of 3. Sometimes you'll do 3 groups of 2. It depends on the proportion, as long as the ratio works. So if you see I had 1, 3, 2, this is also 1, 3, 2, so I knew that it was going to be a good group. I'm not going to have you guys do anything too crazy right now. You'll slowly start to see them more and more. And I'll ease them in. Okay? Now, I just want to kind of go back for a second. And I said in the next video, I am going to show you how to do this one, which is called the difference of two squares, sort of in a shortcut style. But if you wanted to use AC method and grouping, you could. Really what's going on is you have a 1x squared plus 0x minus 4. We do have a quadratic trinomial, it's just that my b value happens to equal 0, okay? Just a little awkward in that sense, but no big deal. So I'm going to still do FML. I'm going to AC. So 1 times negative 4 is negative 4. Remember, A is 1, they're pretty easy. 1 multiplies to give me negative 4. 1 and 4, 2 and 2. B for but what? But it has to add or subtract to give me 0. So which pair of numbers will add or subtract to give me 0? 2 and 2, as long as one of them is positive and one of them is negative. So I'm going to split my middle up into plus 2x and minus 2x. That gives me x squared plus 2x minus 2x minus 4. Underline, underline, greatest common factor. What's the greatest common factor in that first set, that first group? Well, I have x squared plus 2x, which is just x. And then here, my greatest common factor is negative 2. Bring it out front, bring it out front, parentheses, parentheses. Next. Pretzel, pretzel. What goes inside? Okay, reduce each of the ovals, and what goes inside? X squared over x is x. 2x over x is 2. Negative over negative, so plus x, positive x, and then negative over negative is plus 2. If it matches, you're winning at life. Bring it out front. If I factor that out, What's left inside? X minus 2. And we're done zeroing. So it does work, but there's tricks. Now, the cool thing is now we can kind of see why this trick is going to work. We picked the number that was the same number, but one was positive and one was negative, because what that did was it allowed for my middle term, or my b value, to be 0, because essentially they just canceled one another out, and they're gone. And there it is factored. There's a special word to describe expressions of this nature, and that word is conjugates. So conjugates, for example, a plus b, and we'll use a plus sign for and, a minus b. When you conjugate a verb, you keep the beginning of the verb the same, and you change the ending. So that's how conjugates work. So we use conjugates for a lot of things in math. They come in super, super handy, and this is really one of them. So they kind of look like this. They are conjugates of each other. All right? Okay, so here we have some examples that we're going to work on. Now I have a few more little tricks up my sleeve for us. Here, it doesn't look like a quadratic trinomial. I do have a quadratic binomial, but this is a quadratic binomial, and so is this one. But they're binomials in different ways. So in the notes about the example, I'm going to write something down. Here, I'm going to write ax squared plus bx. I know it's a minus sign, but I'm just defaulting to a plus sign to set it up. And here, I'm going to write ax squared minus or plus c. Yeah, I'm just defaulting to a plus sign. So while they're both binomials, they're different. This is two terms where I'm missing the c value. Here I have two terms and I'm missing the b value. So it does make a bit of a difference. Other things for notes over here. You might make a little statement to yourself. G, there's no c. All of a sudden, like, great, how do I factor? I'm F. Not that I can do language. Okay? I'm F. I don't know how to factor this. G, there's no c. I'm F. That's your reminder that we're going to factor by starting with the G, C, F. So we're going to start with greatest, common factor. Okay, so what is the greatest common factor? Now, really what's going on, most of you will be able to do these things in your head, but just to really showcase what's going on. 32. Up here on top of the page, I intentionally had everyone do all these numbers to a power, okay? After a while, you should get very good at them and be able to do these very, very quickly. For instance, 2 to the 0 is 1, 2 to the 1 is 2, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32, and I'm going to pause right there for a minute. If you know these things really well, then you should automatically know that 32 is really 2 times 2 times 2 times 2 times 2. So 5 cubes make 32. And x squared is really x times x. This right here is 32x to the second power. If I had x-ray vision, that's what makes it. Minus 56 is 7 times 8. 8 is 2 to the third. So I have 7, which is already prime, times 8, which is 2, 2, 2, and x. So when I'm doing the greatest common factor, I like to use the story of the greatest con man. Okay? A con artist is somebody who tricks you and swindles you out of, money or whatever. So we're going to be the greatest con man. I have x-ray vision, and I know how much money each of these two people have in their pocket. This person has 5 $2 bills and 2 X dollar bills. And this person has a $7 bill, 3 $2 bills, and an X dollar bill. As the greatest con man, I'm standing outside the door to a circus, and I'm charging admission. And I'm like, oh, you guys should come to the circus. It only costs, and I'm going to claim that it costs whatever they both can afford. Can they both give up a 7? No, only this one has a 7. Can they both give up an X? Or I'm sorry, a 2? They both can give more than just 1 2. They can give me at least 3 each. They also can each give me 1 X. So the greatest common factor of the greatest con man is 2 2 2 X, or, so I'm going to write both ways, 2 2 2 times X, which is equal to 8X. Again, I underlined it and wrote it underneath, but I'm really going to divide it out. If I write that 8X out front, what's left inside? Well, I divide. You are going to do the parcel. So this will divide right here, but it'll also divide right here. In this case, 3 2's cross out, X crosses out. What's left is just 2, 2, and X. So what's 2 times 2 times X? 4X. Here, 2, 2, 2, and X cross out with the 2, 2, 2, and X. I'm only left with 7. So this is done and factored. You know we didn't miss anything. We got it all the way. That's how you ensure you take everything out. Okay? So that is factored form of this example right there. And here's my notes I kind of wrote for myself right there, okay? So the pretzel is there to help us simplify. When the word pretzel, maybe a year from now, you're like, what is oval? And you ask yourself, oh, they're pretzel, okay? Divide, and then you gotta write myself a note, factoring equals undistribute. We're undistributing. That's really kind of what's going on. I mean, distribution is factoring, but I know we associate distributing with multiplication. So I'm just kind of trying to get words to help us understand. So this is what we end up doing when we do factoring by grouping. We're using this greatest common factor in different chunks. So if I go down to this example, it's sort of like the one I did to kickstart everything. So I have 8x squared minus 10x plus 3. FML. I'm going to go to AC. A times C. Well, A is 8. Writing notes. A is 8. B is negative 10. And C is 3. 8 times 3 is 24. 1 and 24. 2 and 12. 3 and 8. 4 and 6. B for but what? But we have to add or subtract to give me negative 10. Now keep in mind, I don't take these examples by mistake. A lot of thought goes into these examples, so they're carefully chosen. What did I carefully choose? If you look, this pair, 2 and 12, and this pair, 4 and 6, can both make 10. We have to watch and be careful because they have to give me positive 24, and they have to add or subtract to give me negative 10. Which pair of numbers do I want to pick? Multiply to be positive, they have to add or subtract to be negative. We need this pair right here. We need a 4 and a 6. Because they can both be negative, which multiplies to be positive, and adds to be negative 10. So I'm going to take my FML and make it into, so it's first middle last, and I'm going to make it into first outer inner last. I'm going to build the quad, okay? So FML, AC, B, but, B for but, okay? Then the M turns into the OI. You are going to build the quad. These are always called quadratics. So let's get 4 terms. No, cut off. Not everything is going to be a quad, but right now, just to help us remember, it's here to help us out. We're going to build the quad. So we use these two numbers to split up that negative 10. So what happens now? I have 8x squared, take away 4x, minus 6x, plus 3. Now we're going to do factoring by grouping. So underline, greatest common factor. What's the greatest common factor? Right here. 4x. So again, just to go back to this, to clarify, I know this makes 10 as well. I would need a negative 12 and a positive 2 to get to negative 10 in the middle, right? However, when I multiply them, that would give me a negative 24, and I need to be a positive 24. So that's what narrows down our list when we go to AC to find our factors, okay? Rewind back over here. What's the greatest common factor between these two terms right there? Negative 6x and positive 3, definitely a 3. And so we sign that's here, so in this case it's negative. Bring it out front, parentheses, pretzel, what goes inside? So the pretzel, okay, the pretzel is going to help me reduce. Sorry, I'm grabbing different colors. So what's left inside after I divide and simplify? I'll have 2x minus 1 and 2x minus 1. If it matches, you're winning at life. Bring it up front. So what matches? The 2x plus 1. They both have it. So I'm going to bring my 2x plus minus 1 up front. And that's linear, so that's good. It's a prime factor, 2x minus 1. If it's quadratic, you want to check the cubic. You want to check. What's left inside? 4x minus 3. So what's the final answer? Let's put it right in here. And you can check every single question, factoring question, by foiling. If you could foil and get back the problem, then you did it correctly. Okay? What questions do we have? When I factor out this negative, so these are both negative right here. When I do my greatest common factor, it's going to be 3, and the sign I choose is the sign of the leader of that group. So this is always going to be positive the way I set them up. So this will never have a sign with it. It's automatically positive. But this, the group, is this like little orange line right here. The leader is negative. So that's a negative here. When you divide each oval, negative 6x divided by negative 3, this is an oval radius of the pretzel, I get positive 2x. And when I divide positive 3 and negative 3, I get negative 1. Okay? Check. So it's not always with an x, because next time this could be x to the 6th and these can be to the 3rd. Like the powers can vary from example to example. It's just in the group, whatever sign the first term in that group is, that's the sign of the thing that goes underneath the greatest common factor. Check any factoring by distributing. So if you distribute back, even if you just distribute in your head, you can check how accurate you are. So check any factoring by distributing. So I put some notes down here. So that should be pretty good. And hopefully this helps clear up any questions in this packet. That should help you at least do these examples, okay? These examples are all sort of set up. Here you're going to take out the greatest common factor first. These first three are pretty classic, just like what we just did. This one is like the x squared minus 4 example. These two are like the ones we just did. And this one is like the first example on the other side. So these 8 examples should be pretty helpful there, okay?